Hello, you and you and you. This is Helen Thomas and the CDFM Study Group. Welcome. All right, today we are going to be continuing review of CDFM Module 4, and we're going to continue with competency number 5, which is in the 2024 study guide. If you have not already subscribed to our YouTube page, I know you can still view the videos, but I will really appreciate it if you will click that subscribe button for me. And also click the notification button at the very top so it'll let you know whenever a new video has been uploaded. All right, let's go ahead and begin. All right, so we've been talking about the acquisition process and how we move from identifying a capability gap to recommendations of courses of actions to fix the capability gap to now we are actually developing that course of action that would meet the warfighter need. So in Module 5, we're moving on to engineering and the technical management of the program, that whole acquisition program. So let's recap a little bit. Remember that the DoD, Department of Defense, Department of War, has 3 support systems. So whatever the mission is of the Department of Defense, they're broken down into these 3 support systems. JCIDS, Joint Capabilities Integration and Development System, PPBE, and the Defense Acquisition System. So once the priorities are identified or the mission for the Department of Defense, then they go through an analytical process, which is done by the Joint Requirements Oversight Council, the JROC. And the JROC is chaired by the Vice Chairman of the Joint Chief of Staff. And so what JROC does is they look at what the mission is, then they look at the capability of the military services to see what capability gaps they have, to identify the capability gap. So they're looking at MLPF is the acronym, Doctrine, Organization, Training, Material, Leader Development, etc. If it's anything other than material, it'll trigger the Plan, Program, Budget Execution System, PPBE. If it requires a material solution, EL, which is a new aircraft, a new type of vehicle to protect the warfighter. If it's a material solution to fix the problem, to fill that gap, then it triggers the acquisition system. So that is how we get into Module 4. So we are developing our system, and then we have to look at the specific technical things that have to be managed in this program. So let's see what they have here. So they're going to systems engineering defined. So they give you the definition. So system engineering is a method or an approach that is used to identify the specifications, the specific things that you need to develop this capability. So we've taken the concept of a capability gap. Now we are actually defining the specific things that equipment, and for example, we'll say an aircraft, that aircraft needs to be able to do to meet that capability and fill the capability need for that warfighter. So whether it can be up armored, if it's let's say a Humvee, they may need more support to protect individuals that are driving in that equipment. So all of those things are look at the specifics. Engineering lets you know it's very detailed. So they're looking at the technical management, the operation, cradle to grave. And then once you get no longer have the life cycle runs out for that equipment, what do you do with it after? So all of that is considered in the systems engineering plan. So there's some key terms that you need to know as you're looking at systems engineering, and they include what is a system versus system elements. So let me look at the definitions that they provide. So as I'm going through, I'm also highlighting things in my book to make sure that I cover specific items. So bear with me. All right, so system, it says an aggregation of system elements and enabling system elements that achieves a given purpose. So a system is has several elements that achieve the purpose of, again, we are developing to meet a capability need. So that system is maintains elements that achieves and fills that capability gap. So the elements can include systems, subsystems, components to it. If you have an aircraft, you have a vehicle, you might have a GPS system that's part of it. It's an external, but you put it together, so different components. So you got to look at all of that. So none of this stuff is, it's it's like way out there. It's kind of like it makes sense if you think about it on just a regular level. All right, so let's see. The role of the systems engineer is to balance the conflicting constraints, cost, schedule, performance, right? So just like the program manager is managing the entire program, the specific engineers, their job is also to manage their level and to notify the higher if anything is identified that's going outside of the cost constraints that were laid out in the beginning. So in the technical processes in systems engineering, you're looking at first the initial capability, making sure you get your prototypes, put them in play. Do they do or fulfill the capability gap that we anticipated to do before we move on to full operational capability? Before we build 1 million aircrafts, we need to know if it actually does what we need it to do. So you start off with initial operational capability. All right, let's see what else we have here. Stakeholder requirements. So I'm only going to be pointing out things. All right, so let's see. There's some terms here, and I remember from the older book. Yeah, so you got to know the difference between validation and verification. So let me highlight that because I remember that came up extensively. So validation, when you're validating the program as you're going through the process, you're validating, is it the right solution to fill the capability gap? That is the question associated with validation. Is it the right solution to fix the problem? Versus verification. Verification said, did you build it right? Did you build it correctly? Based on the specs, the components, what the program manager says is supposed to be able to do, you're verifying. So the best thing to do if you're learning is verify that you build it right. So you put it all together. Did you build it right? You're verifying that you build it right. You're validating if it's the right solution to the problem. So if you make it all in one sentence, it's easier to remember. So let's see, technical planning. So a lot of these are just definition, and these are in the older 2011 book. So I'm not going to, a lot of you have the older book, so you're able to go and review those. So systems of systems engineering. Let's see, you should give a definition. So let's see, system, because they talk about a system, and then a system of various systems. The overall program deals with planning, organizing, analyzing, and integrating several capabilities that they're all going to work together to fill that capability gap. So you have systems of systems, and then there's another term, and I'm going to point this out because I remember this came up extensively in the older book. A family of systems is not considered to be a system per se. They're just in the same family. A family of systems does not create a capability beyond the added sum. So a system of system is when I take several systems to make a larger system, and it gives me a greater capability. Versus a family of system does not give me any additional capability. So that's the difference between systems of systems and a family of systems. Okay, so the complexity of ETM, let's see, engineering technical management. So it's very complex. Okay. I know as I'm reading this, my first time reading through this portion of the book, so bear with me. So a lot of it is straightforward, quality. You gotta look, you gotta consider if I'm building an aircraft, I have to also consider the safety of putting human elements, human error, human personnel, their safety, and look at survivability, how many people, what kind of training they're going to need, what type of personnel support is going to need. So human systems integration is required. You got to look at environmental issues. Can it sustain cold, hot? So all of those are listed. Anti-tamper. I want to make sure that if it gets in the wrong hands, that it's not easily you will not easily be able to tamper with the specifications that are there. So anti-tamper activities are conducted. So they listed a term here called value engineering, which means an analysis of the functions of a program, a system, building, a facility. So we're going to analyze all of this by qualified agencies directed looking at performance, reliability, quality, safety, and life cycle costs. So it's basically doing the same thing. Value engineering mean I want the best job for the best cost. So it's got to balance out. So value engineering is exactly as it says in the word. Now, modeling and simulation is the next topic, and that also comes up a lot in acquisition. So meaning I have a capability and then I need to test it. So modeling and simulation is more of in that testing, putting it into action. So the DoD continues its transformation by increasing the reliability on GPS, global positioning systems. So modeling and simulation occurs throughout the life cycle of a program. That's going to be something important for you to know. When does it happen? When does testing happen? It happens throughout as we're building this capability. So modeling and simulation can represent the system of systems environment. Remember, system of system versus family of systems, right? We got to think about software because we're going to put software into our aircraft, into our vehicle. So all of those considerations, that's why it's so complex, because each one of those different components put all together is what fulfills the capability gap. It's not just aircraft, right? Think about it. So capabilities, there are several capabilities that must be considered that are critical to the program and an integral part of the process. We got to make sure that the program manager has to establish the RAM, reliability, availability, and maintainability. So as we're building this aircraft, we got to make sure that it protects. We got to make sure so safety is included. We got to make sure it fits the capability gap. It's not only safe for the personnel, it's safe for the environment. So all of those considerations supported. The program manager got to make sure we have a life cycle support system. Once we build it, how are we going to maintain it or sustain it throughout the life cycle of the aircraft? So all of those, the support plan, survivability, if it gets hit, what are the chances of survival for our personnel as we put them in there? So survivability is included. Information assurance, the PM should incorporate IA requirements into the program design, because we want to make sure it has integrity, authentication is confidential. So system security is a major portion. So remember, with acquisition, the PM, program manager, is involved in all of this whole process. So 9 times out of 10, if your answer is who does what, it's the PM. Unless you deal with money, then it's the resource manager. So some other considerations the program manager has to deal with when you're working on a program is corrosion, prevention, control, how is the system going to be able, how long is it going to last? Depending on where you're going to keep it, we have to have protective finishes on the equipment, just a whole lot. And some of your equipment, whether it's an aircraft or a vehicle, you may have ammunitions on it. So those considerations, the ultimate objective when designing any type of equipment with ammunition is to develop where there's no adverse reaction to it, right? We want to make sure it's protecting our personnel while they're using it also. It's not going to explode, the ammunitions. Each of our equipment, to include our aircrafts, have specific item, unique identification information. So more like I would associate it with a serial number. It's basically to be able to identify. So to enhance the life cycle management after you build it, they want to make sure they have specific IUID numbers. So let's see what else. A popular term that comes up with acquisition is we don't always develop everything that we use in the Department of Defense. Sometimes we take commercial off-the-shelf products, things that are already out there in the commercial sector that we may be able to use, whether it's some type of technology advancement or there's already a vehicle out there and we just need to tailor it for with the military specifications. Commercial off-the-shelf products are often used because they offer significant opportunities for us to be able to achieve and gain that capability in a quick or faster manner. So we don't have to start from scratch in everything that we do. All right, systems engineering plan, the SEP. This one's important because I remember I've seen this several times. So this, who develops the SEP, systems engineering plan? Voila. The program manager, right? So when is the SEP created? So I will tell you there's two parts. A systems engineering plan is done first at milestone A to support technology development strategy, and then it's done at milestone B to support the acquisition strategy. It's just, you remember you have to look at that chart and then see when things happen. So you do this engineering plan at milestone A just before you do technology development strategy to do technology development and maturation. And then at milestone B, you do it also before you enter into the acquisition strategy, which is the second phase of an acquisition program. Milestone documentation. All right. So then they go, let's see how they end this. I think this is short. Get some question answers. They're pretty straightforward. Yeah. All right. So let's go back. Let me recap some stuff here. Let's see if I discuss milestone A, SEP. So you have material solution analysis and you have milestone A, then you have technology development, technology maturation, and risk reduction. And so what you're going to need to be able to do for this exam is you need to be able to look at the phase and say what's happening at each. So we know that we started off with the initial capabilities document from the JROC to tell us what we need, what kind of capability we need to build. Then material solution analysis, we got guidance from the DK to do the analysis of the alternative. So I'm looking at different courses of actions, and then I want to analyze the courses of action based on my checklist to see which one I recommend that we focus on to build. And so just kind of walk it through that way. It's not just looking at the information, memorizing it, is understanding where it happens in the process. That is the focus for Module 4, is understand where things happen in the process. And I know you guys can do that. And so I think this is the end of the engineering portion. Yes. And so this will end this video for today. I'm going to do another video for the next portion, which is test and evaluation. So again, this is Helen Thomas and the CDFM Study Group. Please, sir, please, ma'am, please subscribe to our YouTube page. Click that notification button so that it'll let you know when I upload a new video. I'm going to do better to try to do more since the government shut down as of this date. I've been having a little bit more time on my hands, so I'm going to go ahead and try to get these videos out before we have to go back to work and try to figure out where we start. All right, so this is Helen Thomas and the CDFM Study Group. I'll see you guys again next time. Thank you.